Hello, I am Michiko Inoue in Dependable System Laboratory, Nara Institute of Science and Technology, Japan. Dependability is a key concept of our laboratory. It is a concept that we can use systems reliably and securely. Our current targets are distributed algorithms and hardware security. Let us introduce these concepts.
Hello, I'm Fukuhito Oshita, an associate professor of this laboratory. First, I introduce researches about distributed algorithms. Distributed algorithms are algorithms for distributed systems, such that lots of computers or robots cooperatively execute tasks. I think you are not familiar with distributed systems, but surprisingly, most systems in the world are distributed systems. In our laboratory, we consider many types of distributed systems, from global scale systems to nanoscale systems. For various types of distributed systems, we develop self-stabilizing distributed algorithms. Distributed systems include lots of computers or robots, and so we cannot avoid faults of the computers or robots. But self-stabilizing algorithms can guarantee that systems recover automatically from such faults. This property is very good, but the design of such self-stabilizing algorithms is not so easy. Nodes cannot know information of distant nodes instantaneously, so they just communicate with nearby nodes and so decide their behaviors based on only local information. But still, globally, they have to become stable. To realize this property, we develop new algorithms. Design of such algorithms is not so easy, but it's very interesting. As other topics, we develop algorithms for mobile agents and mobile robots. Mobile agents are software programs that move autonomously in networks. And mobile robots are physical robots that move autonomously in the plane. We try to make algorithms such that lots of mobile agents or robots cooperatively execute some tasks. In particular, for mobile robots, we conduct experiments with 150 kilobots and 15 Kepler-4 robots. Here, as an example, I introduced an algorithm that achieves exploration by a team of low-functional mobile robots. These robots can just observe their neighboring nodes and decide their movement based on the local view. But by this team, they can explore the environment like this. Similarly, by developing these types of algorithms, we expect that a team of cheap low-functional robots can achieve the same performance as an expensive high-functional robot. We also consider more low-functional robots called nanoscale systems. We try to reveal what function can be realized by lots of very small low-functional robots in the nanoscale world, such as the inside of our body. In this example, robots just float in the water and change their states on the collision. But by repeating the collisions, they can make groups with the same size. This is an example of 3 partitions, but they can make any number of groups.
Hi, my name is Michio Shintani. Thank you for your interest in our research. The Dependable Systems Laboratory is engaged in research on improving dependability in various devices, including silicon integrated circuits. In recent years, many studies on machine learning represented by deep learning have been conducted. In order to perform this machine learning efficiently, a hardware accelerator that performs machine learning itself at high speed is indispensable. In particular, the neomorphic circuit that imitates the human brain is a typical example. The neomorphic circuit is constructed using recently discovered passive elements called memristors. By implementing the memristor with a crossbar array structure, the relationship between current and voltage can be supported by multiple accumulator operations. This allows us to efficiently perform large-scale multiple accumulator operations. However, the memristors have the problem of reliability due to the immature manufacturing technology. Since it has extremely short lifetime compared to widely used silicon, it will have failure with use, and as a result, the recognition accuracy will decrease. To solve this issue, the Dependable Systems Laboratory is engaged in research on reliability improvement of neuromorphic circuits. In the previous slide, we introduced a research on improving the reliability of machine learning itself, but we are also conducting the research to achieve high reliability using machine learning. This research is conducted using actual mass production LSI test data provided by semiconductor companies. By learning the test data using neural network, it becomes possible to detect failure bad chips that were previously difficult to detect. Next, we'd like to introduce research on detecting recycled FPGAs, that is, used FPGAs. In recent years, it has become a big concern that used FPGAs are marked again as new ones. We have proposed an analysis method for efficient detection of recycled FPGAs. In the evaluation, the FPGAs are actually operated for a long time to simulate the actual situation. We are also conducting research on power devices. Currently, attention is focused on next-generation power devices such as silicon carbide, which has high power conversion efficiently. In order to efficiently manufacture circuits using silicon carbide, design optimization using circuit simulation is indispensable. For many circuit simulation models, simple models using empirical mathematical formulas are widely used. But we have developed a highly accurate circuit simulation model based on device physics. In particular, evaluation of self-heating characteristics is very important in power converters. But by using this model, not only electric characteristics but also temperature characteristics can be calculated at the same time. Currently, we are developing it in collaboration with major domestic and overseas power electronics vendors to put into practice. Finally, I'd like to introduce our research on decimal computing. As you know, calculations in computers are done in binary. This is due to the ease of calculation and implementation. But an error will occur as increasing the number of digits. This error is negligible. It might be negligible in many simple calculations, but it is a very big problem in finance. We have proposed a circuit architecture that efficiently performs decimal calculation by co-designing hardware and software. The evaluation used the open architecture RISC-V, which is also used in companies. The evaluation environment is now also open to the public. Thank you for your interest.
Thank you very much for having interest in our laboratory. For more details, please contact us. Thank you. Bye.